Hello and welcome to this presentation for the ISC Exhibitor Forum. My name is David Power and I'm the head of HPC at Boston Limited, and today I'm going to be talking about how AI and cloud technologies are beginning to influence architectural decisions in the context of genomic sites and genomics workloads. So let me start off by just introducing the Boston Group. We've historically been a global partner of Supermicro for the last 28 years. More recently, we have joined forces with the 2CSI group, and we have offices throughout the world, manufacturing technical capabilities and resources locally within your region. So please reach out to us. As part of the process of delivering complex solutions and HPC solutions, we take a holistic approach towards from inception to the actual decommissioning of the system. We try and work very closely with our customers in terms of analyzing requirements and getting them early access to kit to do R&D, testing, proof of concept, working. And throughout the life cycle of the system, we've dedicated project teams that will work with customers to complete scope of works documents and ensure that logistics and projects are delivered on time and on budget. We have a dedicated HPC build facility where we can actually go and build solutions in their entirety to verify the inter-component interoperability within the system to ensure that everything is working as it should when it's delivered. And we also provide a kind of a traffic light report to verify that all the components are performing at the expected levels so that we can rerun health checks periodically throughout the duration of the cluster's life cycle. Boston, as a service provider, has a range of solutions that can fit pretty much any need that is out there. But today we're going to sort of focus on the blurring lines between HPC and cloud. So for that, I'm going to introduce a product that we work with called vScaler, which is a cloud technology platform which we've built a lot of our HPC capability in on top of. So we use OpenStack at the under the hood at the foundation of the product, and we've actually built a lot of capability that on top of that to allow people to spin up HPC environments. We have containerized registries for the applications with multi-tenancy capability so that we can do collaborative working within this environment as well. And yeah, really it's been sort of designed from the ground up to be incredibly high performance and to run HPC simulations at scale on top of that. It's been a project that we've been working on for the past 7 or 8 years now at this stage. But yeah, we started off very much as a very HPC focused product. But over the years, we've sort of seen quite a broadening in terms of customers and use cases for our product as well. So we've actually got vScaler now running within the financial industry, financial services, broadcast and media customers. We've of course got lots of traditional HPC customers and organizations in the telco space and even autonomous vehicle space as well. So it's reassuring to see that every vertical out there has a demand for scale and performance. Okay, so if we kind of hone in a little bit more on the genomics side of things, we've put together a product that really allows organizations to be responsive to the changing needs of users and workloads as time evolves. What has traditionally been batched focused workloads, which lots and lots of sequential jobs and big access to or parallel access to back-end data sets. We're really beginning to see a kind of a new range of users coming on board that are putting different sorts of pressures on back-end systems by demanding slightly different software stacks, looking at different frameworks, wanting to explore how tools and technologies like AI can help them shift through these huge genomic data sets. And that's putting a lot of challenges on traditional infrastructure. So with HPC systems, traditionally they've been fairly statically configured with perhaps a modules environment for applications. But what are environments doing now for users when they want to bring their own containers? They want to check and work with maybe Hadoop or Spark or Jupyter notebooks to interact with the data sets in the background. And how can we ensure that HPC providers are, giving users that flexibility in terms of an environment to work off of. At a high level, the software architecture for vScaler, we've spent an awful lot of time working on this vScaler OS product. This is the brainchild of the system, so it handles all of the provisioning and configuration of our cloud environment. So we can actually just do plug and play with regards to hardware for scaling up or even scaling down. And vScaler OS will automatically identify the additional systems that have been added to it. We can tag resources as they're getting integrated, and then it will do the post-production monitoring and preemptive checking of the entire hardware state to make sure that everything is working as it should as well. Now, over the years, this will look perhaps slightly familiar if you've seen any OpenStack presentations in the past, but every block that you see on this diagram, we've taken time to go out, enhance and optimize on what's available sort of upstream for this product. And I won't spend too long speaking about every single block here, but the identity services one we've spent quite a bit of time on as a result of the collaboration we've had with our financial services partner. Traditionally, the identity service was a fairly basic username and password type combination, but to comply with their governance and security regulations internally within the bank, we needed to have biometric authentication and multi-factor authentication built into the platform as well. So that's all readily available and part of the stack as well. So yeah, at a high level, this is kind of what we're looking at with the platform. We have this self-service portal that allows researchers to come in and provision whatever environment they feel like they need to use as part of their research. We've obviously started off with HPC as one of the initial software stacks that we created and support on top of the platform. And we can actually mix and match virtual machines with bare metal machines. So we can actually have things like head nodes, login nodes, web services, portals, databases, all of these can be virtualized as the peripheral components of the HPC cluster. These can then be set up in a highly available manner. They can be snapshotted so that you can have instant recovery in the event of some catastrophic failure. And then we bare metal provision the actual compute server so that there's no overhead in terms of virtualization layers. So this kind of combines the flexibility and ease of management of VMs with the raw performance capabilities of bare metal servers, all within a single cluster. And these can be provisioned in a multi-tenant type of solution as well. So you can have dedicated research HPC environments on top of your vScaler platform, where you could have one perhaps highly secure environment that's partitioned off for commercial collaboration with external organizations, and then maybe a more traditional general purpose user cluster where the vast majority of your researchers are actually working on there. But yeah, as well as the HPC side, obviously we can support Hadoop and Spark, and they can all be created from the self-service portal. We've spent quite a bit of time working on the AI and deep learning side by integrating GPUs. So we work with virtual GPUs, PCI pass-through, and we can bare metal provision systems like the DGX and other ones. And I come back to that now in a couple of slides actually, so I'll hold off until then. Finally, we've a fairly modest public cloud that we've kind of been using for development purposes really over the last number of years. But we've built a layer of integration with our systems on our public cloud where we can either extend and push workloads out into the cloud, or just replicate the environments that we actually have on-prem out in the cloud for any high priority projects which need perhaps a very fast turnaround time, as opposed to just scaling out your on-prem system. So yeah, we've got that kind of hybrid capability within the platform as well. So yeah, some of the kind of high level features within the product as well. I mean, we've spent a huge amount of engineering time trying to make OpenStack more manageable. So it's an integrated distribution with lots of intelligent management on there that's designed to be easy to manage and easy to maintain, unlike some of the upstream components that you'd find as part of it. All of the cloud services are fully containerized. We maintain our own registry where we actually go through continuous integration and validation on our platform. We've got a 1,000-point health check to ensure that all of the features and functions and performance levels are met on the product before it's snapshotted for release for our customers. We can do rolling upgrades. There's no single point of failure, and all that kind of stuff that you'd expect from kind of like an enterprise grade system. So I'm going to just spend a little time. Over the last 6 to 9 months, we've actually been working with a fairly large genomics customer here in the UK. And we had one of the challenges we had was that they were currently running their entire estate out in a public cloud provider. And they had, obviously, they did projections in their roadmap for how many genomes that they wanted to sequence. Over the next number of years, they're looking to sequence about 5 million genomes. And if they were to extrapolate the costs of that in the public cloud, it very quickly became quite cost prohibitive. So we were able to put in essentially a fully managed service using this vScaler cloud platform, combining VMs plus bare metal provisioning of the compute environment with an NVMe parallel storage system behind it for a fraction of the price that it was going to cost to run in the cloud 24/7. So, I mean, cloud is an incredibly useful resource, which, when utilized properly, is incredibly effective. But when you're running 24/7 and moving, massive data sets in and out of it, it can be quite expensive. So yeah, that was the initial starting point, say, for this initial customer. And what we wanted to do as well is they'd hundreds of users, and lots of these were possibly internally within the organization, but they'd also a lot of external collaborators as well. And they had an initial configuration, which was it was Ubuntu and LSF, and they wanted to get from that operating system and scheduler over onto CentOS and Slurm environment, but to quickly transition users off of the public cloud environment. We wanted to essentially provide a kind of a frictionless transition over into our platform. So we replicated the environment that they had in the public cloud and spun it up in our environment to start with. And this allowed us to, get a lot of users off of the public cloud environment with very little resistance, because we essentially imported the images that they were using out in the cloud and then spun them up in our own environment. So we were able to take all of the modules environment, the applications, it was completely consistent, and they got an immediate bump in performance because of the latest generation hardware that we were using under the hood. So once we were able to reduce the costs on the public cloud environment and slowly migrate users across, what we began to do then was actually spin up a secondary cluster. So again, while we kept the cluster number one on board, kept all the users on there, we were able to drain a couple of nodes from that. And because everything under the hood at vScaler is completely API driven, it's cloud driven, so it anticipates this flexible dynamic reconfiguration of the overall environment. We were able to drain nodes, spin up a new cluster. So with this one, we introduced CentOS and kept to the LSF scheduler for the time being. But during this phase, we actually started to rebuild a lot of their applications. So we were providing this as a managed service. We had about 800 or so applications to rebuild and roll out, and we got a couple of the power users over onto the system initially to just test, verify, and validate. And then once they were happy with the, I think we had about 80% application coverage at that stage, we then started to drain nodes from the first cluster and just moved them across into the second one. So again, what users on the first cluster experienced was, essentially an increase in wait time, but they were still able to go and use it. And obviously the incentive was, if they were happy to start looking at the new cluster, test and verify their applications with the new operating system, wait times and performance wait times reduced and performance increased. And we're still in the transition. So at this stage now we have the third cluster, which is set up, and we've just started migrating larger pools of resources over onto this cluster. It's worth sort of noting at this stage that there is even some users that are still back on cluster one. It's sort of a can't move, don't want to move scenario there, but I'm hopeful we shall migrate them across soon. But with the new scheduler, this cluster 3 became their CentOS plus Slurm setup. And at this point, we actually also introduced containerized workloads. So we've been working quite a bit with the Singularity toolchain and essentially creating a software registry with a lot of bioinformatics pipelines and tools that are sort of pre-configured, ready to just be pulled down within this containerized software repo. So with that enabled, they can actually go back now, and even if they're on cluster 1 or cluster 2, we've Singularity enabled throughout the board there, and users are actually able to, regardless of what cluster they're on, start to benchmark, test, and verify that everything is producing the expected results that they wanted with this containerized registry behind the scenes. One of the other nice things we were able to do with this particular customer was, they wanted to set up, they have a number of internal developers who are working on creating software for their researchers. Now, traditionally, they had a sort of a dev queue on the standard large cluster that was shared with everybody. And when they wanted to go and run their validations or continuous integration overnight, they'd have to queue up the jobs, they'd go and get built overnight, and the next day they'd see their results. Now, because we essentially are running sort of a cloud platform, we were able to just give them their own dedicated virtual development environments. So they now have essentially the 3 clusters that you see there. They have small development versions of each of those, so that they can actually test their software stack against the different operating systems and the different schedulers. And it's kind of more instant as well, because there's no wait times on these dedicated clusters. One of the next things this customer wanted to investigate was they had a small VMware estate which was running some of their core infrastructure, so things like time services, LDAP, DNS, and a couple of Windows-based VMs. And yeah, they wanted to sort of experiment and see, can this infrastructure actually run these in environment for them. And yeah, there was no problem. We have a number of tools that we can actually use, which will go into like an ESXi environment, pull down all of the VMDKs, convert them into QCOW, import them back into OpenStack, and bring them back up. So it was actually a fairly seamless process for them. So as well as now running the core HPC environment, we're also running a lot of the infrastructure VMs as well as part of this setup. With the number of external collaborators that they had, and one of the challenges they had previously as well was collaborating and visualizing incredibly large data sets. So there'll often be scans or molecules or 3D renders of proteins that they want to be able to go in and manipulate and rotate. And as part of the system, we've got a number of vGPU capability enabled, which allows them to create VNC sessions through our portal with GPU accelerated rendering happening in the background, and multiple researchers are able to connect into this same session to collaborate together. So they have in effect workstation capability within the platform that can be spun up, which gets spun up and scheduled through the Slurm queue and has access to the data sets directly going across a 100 gig fabric into an NVMe parallel file system. So there's no challenge around pulling data sets off onto their local workstations and then doing like a share screen session with somebody else. They can just remote into the cluster, perform all of the rendering and manipulations that they want to there and then, and yeah, then release the system back for additional workload once they're finished up with it. One of the other things we've enabled is we've got kind of Spark and Hail clusters on demand that are now configurable for users to come in and actually work with. So this is a direction I think that the Broad Institute are going with the GATK pipeline. And yeah, we can have these again in the same manner that we can spin up standard HPC clusters. We can spin up these Spark and Hail clusters for these researchers as well, which again have then direct access into the data sets that they're working off and manipulating in the background. So it's about, hey, we're really just trying to accommodate whatever the researchers prefer in terms of their environment, and just ensure that it's easy to set up, deploy, and configure to allow them to get straight down into the more important stuff. Yeah, as part of this, I mean, they have a number of researchers who are evaluating the benefits of AI tools and techniques as part of their overall methods to shift through these huge data sets. And we're seeing a lot of AI workloads actually being deployed and run on top of Kubernetes with GPUs passed through to them. So again, this is all part of the platform that we've provided as well. And one of the areas that they were quite fond of, which I think got us the award in the end run, was this ability to have secure and dedicated commercial collaboration areas within the cloud platform. So in the same way you can go to any cloud platform, it's a multi-tenant environment. we can spin up very secure lockdown environments for, when this particular customer wants to collaborate with external pharmaceutical organizations or drug development organizations. They can, essentially map specific volume sets to this VXLAN enclosed HPC cluster. It's a direct replica of all the other clusters, but then we restrict the users that can actually get on there just to the external collaborators and the researchers that they want to actually go and work with. So standard users have absolutely no visibility of what's happening in this shared secure environment. And this customer then is ticking all the boxes in terms of compliance when it comes to GDPR and data sets and governance across those. Finally, again, as part of an initiative to kind of make HPC more accessible for a wider range of users, we've obviously developed this user portal, which will allow users to come in who don't necessarily have experience with using command lines or Linux systems. So they can log into this web portal, and through there they can actually manipulate and submit workloads through Slurm from the just a submission form. We can do things like create Jupyter notebooks or Studio on top of here, where actually users can go in and do interactive workload on top of the system. These get provisioned on the bare metal cluster, so they're leveraging all of the performance of the hardware that's actually out in the system, and they can actually go out and spin up these virtual desktop environments from here as well. So they don't have to, SSH in and use VI and SBatch and all those commands if they're not overly familiar with it. And this helps with, again, onboarding new users who perhaps haven't got the experience with using HPC systems traditionally, or might have just been working on their desktops previously. We can give them that same sort of look and feel, but with maybe 60 odd cores under the hood and a terabyte of memory to work with instead of whatever they were working off with their laptop. And yeah, finally, as part of obviously this burst capability we have, we can go out and replicate any of these environments out in the public cloud, and we've been working with AWS, Azure, and Oracle over the last while just to replicate these environments and help extend the customer with instant access to resources out in the public cloud. Okay. I'll just make a brief mention actually of the AI reference architecture. So AI has obviously become quite a prominent force in HPC workloads, but the software stack that goes with it can either be retrofitted to a traditional Slurm type cluster, or people may want to go with things like Kubernetes. So with vScaler, you can obviously deploy whatever the software environment is as and when you need it, and we've done quite a bit of work with integrating all of the NVIDIA tools onto the platform. So whether you're using Rapids or DevOps or Kubernetes, you can go into our self-service dashboard. That'll handle all of the setup and configuration of these environments. And users can just get down to the more important stuff then afterwards. But yeah, if you're interested in more of that, go to vscaler.com/AI, and there's a good white paper there with lots more good information on it. Some of the other nice features I guess we have within the platform is it's all sort of multi-cloud enabled. So if you had an organization that was somewhat geographically distributed, you could have a core site which runs the main infrastructure, and then remote or edge areas which could run replicas but on a smaller scale of the environment that you have within the platform. So we fully support that. And yeah, in terms of migrating to and from our environment, also we've partnered up with HiStacks recently, and yeah, so this is what we've been using to help import images from places like VMware, or even taking images off of existing public cloud providers. We can do V2V and P2V and all that kind of good stuff in terms of conversion of images. But yeah, we can also then leverage public cloud as part of our target platform. So if organizations wanted to have some sort of a backup and disaster recovery strategy, or do some kind of VMware live cloud migration or backup disaster, we can enable users to go and push out whatever workloads or data sets they want out into the public cloud as well. So we fully support all of that. Okay, I think that draws me to a close. If you have any further queries, you can kind of reach out and find us either at boston.co.uk or vscater.com. Thank you very much.